Hello students, we are discussing redox reactions. Today's topic is oxidation number. We know that in case of ionic substances, we have ionic substances. What are ionic substances? Where we have a cation and anion. Cation loses electron and anion picks up that electrons, and the two have opposite charges and they are held together by electrostatic force, and that force we call it is ionic bond. In those cases, that is in ionic substances, electron transfer can easily explain the redox reaction. It can we can understand, we can know that the atom which loses electron is oxidized, and the one which gains electrons is reduced. For example, NaCl, we have NaCl. Here Na loses electron and chlorine picks up this electron. So sodium is oxidized and chlorine is reduced. But it is not easy to explain the redox reaction in case of covalent compounds where there is no transfer of electrons. In order to solve this problem, chemists have assigned an oxidation number or oxidation state here, an oxidation number or oxidation state to each chemical species, whether it is ionic or it is covalent, both. According to a set of rules. There some rules have been devised according to which we can say what is the oxidation number of a particular species. The concept has been very useful in balancing redox reactions. It is defined as, oxidation number is defined as a charge which an atom of an element has on its ion. This is in case of ionic compound. When we have ionic compound, for example, we have sodium chloride, sodium has positive charge and chlorine negative charge. So it is oxidation number is +1 and it is -1. Okay. This is in case of ion, the charge which an atom of an element has in its ion or appears to have when present combined state with other atoms, when it is combined by a covalent bond. In that case, the charge which appears to be present on an atom, that too is its oxidation number. Oxidation number also gives a charge which an atom appears to have when all other atoms are removed from it as ions. When we have an atom which is combined with others, when we remove other ions from it, then if it has some charge, that charge it is oxidation number. During such removal of electrons on atoms are counted according to the two arbitrary rules. Two arbitrary rules have been devised by scientists which determine the oxidation number of that species, of that atom. The rule first is the electrons shared between two like atoms are divided equally between the two atoms. For example, we have H2 molecule. Here we have like atoms, hydrogen. These are two hydrogen atoms. Okay, each hydrogen atom has one electron. When we separate this, each will get one electron out of this shared pair, because the two are equally, they have exactly equal electronegativity. They have equal attractive power for these electrons. So when we separate these two hydrogen atoms, each gets one electron, and we know that it has only one. It has also one proton. When it has one electron and one proton, it means its charge is 0. So oxidation number of hydrogen in hydrogen molecule is also 0. What does this 0 signify? It signifies that when we separate a hydrogen molecule into atoms, the charge of each ion is 0. Okay. So this is first rule. When it is shared between equal, when a covalent bond is formed between two like atoms, the oxidation number, oxidation state of those atoms is 0. The second rule is when it is shared between two unlike atoms which have different electronegativities. For example, we have HCl. Chlorine has more electronegativity. So we assume that when we separate this electron pair goes with chlorine because it is more electronegative, it has more attraction. So when it gets both electrons are pair, then it has one electron in excess of the number of protons present in its nucleus. So it gets a negative charge. Hydrogen has a proton, but it does not have an electron when it is separated from HCl. So in this case, hydrogen has +1 oxidation state and chlorine has -1 oxidation state. So oxidation state has positive, 0 or negative. Now let us see some general rules which determine oxidation number of atom in a molecule. number one, first is the oxidation number of an element in free state or elementary state. When it is free, for example, we have helium, we have neon, they are free, they exist in nature in free state. So their oxidation number is always 0. And also those which are elemental gas, which are in elemental state. For example, we have H2, it is elemental gas, then we have oxygen, we have ozone, we have iron. So they are in elemental form, they are elements. In this case, the oxidation number of their atoms is 0. This is rule number first. Second rule is the oxidation number of an element in a single monoatomic ion. Monoatomic ion is which has only one atom. We have sodium, we have calcium, we have aluminum, we have sulfate. So in these cases, the oxidation number of the atoms is same as the charge on the ion. For example, we have sodium. Sodium has a single charge +1, so its oxidation number is +1. Calcium has 2 positive charge, so its oxidation number is +2. Aluminum has +3, its oxidation number is 3. Chlorine has -1 charge, so its oxidation number is -1. So these are two rules. Third rule is in binary compounds of metal and non-metal. And compound is formed between a metal and a non-metal, the oxidation number of metal is always positive. For example, we have for example, sodium chloride. This is metal and this is non-metal. So the oxidation number of metal is always positive and that of non-metal is always negative. So this is rule number third. Rule number fourth is in compounds formed between two non-metallic atoms. For example, we have NH3, ammonia. Nitrogen is non-metal, hydrogen is non-metal. In these cases, the oxidation number of that element which has a higher electronegativity has negative value, and that which has a lower electronegativity is positive. For example, in this case, ammonia. Nitrogen is more electronegative than hydrogen. So the oxidation number of nitrogen is -3 and oxidation number of hydrogen is +1 here. In case of nitrogen iodide, Ni3, the oxidation number of nitrogen is here +3 because it is oxidation number, this electronegativity is less than iodine. Rule number 5 is in all compounds of hydrogen, the oxidation number of hydrogen is positive in almost all compounds. But in hydrides of active metals are which are more reactive, which have more tendency to lose electrons. We have lithium hydride, we have sodium hydride, potassium hydride. In these cases, it is -1. So normally it is +1, but when it is bonded to, when it has covalent bond with more active metals, then these hydrides, in these hydrides, hydrogen has the oxidation state of -1. Oxidation number, oxidation state of oxygen is -2 in most cases. In most cases, -2. However, in peroxides, H2O2, hydrogen peroxide, sodium peroxide, and superoxides, potassium oxide, it is -1. So normally it is -2, but in case of peroxides and superoxides, it is -1. In compounds of oxygen with fluorine, when it is bonded to fluorine, for example, we have dioxygen difluoride, and we have oxygen fluoride, OF2. O2F2, which means that when it is bonded to fluorine, we know that fluorine is the most electronegative element. In these cases only, it has positive oxidation number. Normally it has -2. Here it has, in this case, it has +2 in dioxygen difluoride. In case of oxygen fluoride, it is +1. Okay. Then seventh rule is the most electronegative element in the periodic table, which is fluorine. Fluorine has always oxidation number of -1. It has always oxidation number of -1, oxidation of -1. The other halogens, we have chlorine, we have bromine, we have iodine, they have +1 or -1. -1, they are when they are bonded to less electronegative elements, and +1 when they are bonded to a more electronegative atom, the atom which is more electronegative. So this 7th, then is 8th rule. The sum of oxidation numbers of atoms in a molecule is 0. For example, in ammonia, nitrogen has -3 and 3 hydrogen atoms have +1, +1, +1. So the net oxidation number, the sum of oxidation numbers of all atoms in a neutral molecule is 0. But in case of polyatomic ions, which have charge, for example, we have sulfate ions. the oxidation number of all atoms is equal to the charge on the ion. For example, in this case, in case of sulfur, the oxidation sum of oxidation number of sulfur and four oxygen molecules is equal to the charge on the molecule, that is -2. So it is sum is equal to -2. Sum of the these oxidation numbers of all atoms in a polyatom ion is equal to the charge on the ion.